We've uh we've been on vacation for a while.
Oh, yeah.
Sorry for pausing the publish for a few days.
Right. Right.
But
Welcome back.
we're back.
Yeah.
And diving into a topic you specifically requested. Setting up a functional Kubernetes cluster.
Nice.
You've got your cluster up and running. That's awesome.
Yeah.
But now you might be thinking,
Okay.
okay, what do I actually do with this thing?
Right.
It can feel overwhelming.
Absolutely.
So let's break down the essentials
Sure.
for a functional, reliable, and manageable setup without getting bogged down in every possible tool.
Yeah. Keep it simple.
We're going to unpack this fantastic guide that lays it all out.
I love that this guide really focuses on practicality.
Absolutely.
It's easy to get lost in the weeds with Kubernetes.
Oh, yeah.
There's so much you could do.
Right.
But focusing on the core functionality first will save you headaches down the road.
For sure. And this guide seems to take that approach, starting with the most fundamental piece of any application. Storage.
Makes sense.
Where do I put my data?
Right. Your apps need a place to live,
Okay.
especially databases like Postgres or anything requiring persistent data that survives pod restarts.
Right.
The guide lays out some great options, each with its own use case.
It really does feel like a choose-your-own-adventure for storage.
Yeah.
There's the local path provisioner, which seems perfect for dipping your toes in.
Yeah, for sure.
The guide even calls it quick and dirty. I love that
Yeah.
honesty.
It's great for testing or development where high availability isn't critical.
Okay.
But the guide rightly points out that if you need your data replicated and protected from single points of failure,
Right.
you'll want something more robust for production.
And that's where Longhorn comes in, right?
Exactly.
It's presented as a good step up in terms of high availability without being overly complex.
Longhorn achieves this by mirroring your data across multiple nodes.
Okay.
This means that even if one node crashes, your application can keep running using the data on the other nodes.
Gotcha.
And setting it up is surprisingly straightforward, which is a huge plus.
Yeah. Nice. Now, the guide also mentions RookSF, describing it as a powerhouse.
Yeah.
What makes it so powerful compared to something like Longhorn?
RookSF offers advanced features like self-healing and auto-scaling that Longhorn doesn't. It can handle massive amounts of data and complex storage requirements.
Okay.
But that power comes with increased resource demands and complexity.
Right.
It's not something you just throw into a small cluster without careful consideration.
That makes sense. But there are a couple more options on this list I'm curious about.
Okay.
One is SeaweedFS,
Mm-hmm.
which the guide says is lightweight and has built-in S3 support.
Right.
What are the implications of that S3 integration?
SeaweedFS is intriguing because it's designed to work seamlessly with object storage like S3.
Okay.
This means you can leverage the scalability and cost-effectiveness of cloud storage directly from your Kubernetes cluster.
Interesting.
It's particularly appealing if you're already heavily invested in a cloud ecosystem like AWS.
So if I'm already using S3 for other things, SeaweedFS could be a natural fit.
Precisely. It simplifies data management and avoids the need to run separate storage infrastructure.
Okay, and lastly, there's OpenEBS. What makes it stand out from the other options?
OpenEBS gives you granular control over how storage is handled at the container level.
So more fine-grained.
Yeah, if you need that level of customization and want to really fine-tune your storage performance for specific applications, OpenEBS is worth exploring.
Gotcha.
But for most use cases, the other options we've discussed will likely be sufficient.
Okay, so we've got our data taken care of. What's next on the roadmap to a functional Kubernetes cluster?
Okay.
The guide seems to jump right into Ingress,
Right.
which I remember being a bit of a head-scratcher when I first learned about it.
Ingress is essentially the entry point for external traffic into your cluster.
Okay.
It acts as a reverse proxy, directing requests to the appropriate services running inside Kubernetes.
So
Without it, your applications would be isolated and inaccessible from the outside world.
if I have a web app running in my cluster, Ingress is what makes it accessible to users on the internet.
Exactly. And there are various Ingress controllers to choose from, each with its own strengths.
Right.
NGINX. Ingress is a popular choice. It's reliable and widely used.
NGINX is a familiar name. It seems like a solid default option unless you have specific requirements, right?
Absolutely. But the guide also mentions Trafic,
Cool.
which stands out for its ease of configuration and built-in Let's Encrypt support.
Hold on. Built-in Let's Encrypt.
Yeah,
That sounds like a huge time saver.
it is.
Does that mean I don't have to mess around with certificates manually?
Precisely. Trafic takes care of obtaining and renewing SSL certificates for you, simplifying the process of securing your applications.
Wow.
If you value simplicity and automation, Traefik is definitely worth considering.
This guide is really hitting all the right points so far. Speaking of security, I'm guessing SSL certificates are non-negotiable these days.
Oh, for sure.
Especially for publicly accessible applications.
You're absolutely right. Exposing services without HTTPS is just asking for trouble. And thankfully, the guide highlights a tool that takes the pain out of certificate management. Cert-Manager.
Okay, tell me more about this Cert-Manager. It sounds like a lifesaver.
Cert-Manager automates the process of obtaining, renewing, and managing SSL certificates.
So it does everything.
It integrates seamlessly with Let's Encrypt,
Okay.
a free and widely trusted certificate authority.
Right.
This means you can say goodbye to manual certificate generation and renewal,
Nice.
saving you time and effort.
So even if I'm not using Traefik, I can still leverage Cert-Manager to streamline my SSL workflow.
Exactly. Cert-Manager works with a variety of Ingress controllers and can be used to secure any application running in your cluster.
I'm adding that to my must-have list. Security made easy, just what I like to hear. But even with a secure and accessible cluster, it's still a bit of a black box without proper monitoring, right?
For sure.
How do I know what's happening under the hood?
You need visibility into your cluster's performance and health.
Okay.
Otherwise, it's like driving a car with a blindfold on. The guide recommends a layered approach to monitoring, starting with the metrics server.
Metrics server. Is that like a basic health check for my cluster?
It provides essential metrics like CPU and memory usage for your pods and nodes.
Okay.
It's a good starting point.
All right.
But for a more comprehensive view, you'll want to step up to Prometheus and Grafana.
The dynamic duo of monitoring.
I've
I've heard great things about them, but I'll admit, I'm a bit intimidated by the setup.
Sure.
Is it as complicated as it seems?
Prometheus and Grafana are more involved, but they offer incredible power and flexibility.
Right.
Prometheus collects a wide range of metrics,
Right.
and Grafana allows you to visualize that data in beautiful, customizable dashboards.
Yes.
You can track everything from application performance to resource utilization, giving you deep insights into your cluster's behavior.
So metric server for a basic overview and Prometheus-Grafana when I need to get really serious about monitoring.
That's a good way to think about it.
Yeah.
And the guide also mentions Loki, which is a lightweight logging system specifically for Kubernetes.
I do love a lightweight solution. How does Loki differ from traditional logging tools?
Loki is designed for the dynamic nature of Kubernetes.
Okay.
It efficiently collects and indexes logs from your containers, making it easy to troubleshoot issues and understand how your applications are behaving.
So it's more focused.
Yeah, it's a great complement to the metrics collected by Prometheus.
All right, so we've got our monitoring stack figured out. What's next on our journey to Kubernetes mastery?
Let's tackle one of the biggest pain points of managing a Kubernetes cluster: deploying applications.
No.
Manually deploying YAML files can get tedious and error-prone,
Oh, tell me about it.
especially as your application grows.
YAML files can be a real headache. The guide mentions GitOps as a solution.
Right.
Is that what we need to conquer the YAML beast?
GitOps is a game changer. It brings the power of Git, the version control system, to Kubernetes deployments.
Okay.
It allows you to manage your entire cluster configuration, including application deployments in Git repositories.
So instead of fiddling with YAML files directly,
Yeah.
I can use familiar Git commands to manage my deployments.
Exactly. And there are several GitOps tools to choose from.
Okay.
The guide highlights two popular options, ArgoCD and FluxCD.
Okay, let's break those down. What are the key differences between ArgoCD and FluxCD?
ArgoCD boasts a sleek web UI,
Oy.
making it a great choice for teams who prefer visual interfaces and collaboration features.
No.
You can easily see the state of your deployments, track changes, and roll back to previous versions.
Visuals are always helpful, especially when dealing with something as complex as Kubernetes deployments.
On the other hand, FluxCD is known for its lightweight nature and seamless integration with existing Git workflows. If you prefer a more CLI-centric approach and value a streamlined, automated experience, FluxCD might be a better fit.
So ArgoCD for visual learners.
Yeah.
FluxCD for command line ninjas.
Exactly. It comes down to personal preference and how you prefer to interact with your tools.
This is all great information. I feel like we're making serious progress in building out our Kubernetes toolbox. What else do we need to consider for a truly functional and secure setup?
Let's talk about secrets management.
Okay.
You'll inevitably have sensitive information like API keys and database credentials
Right.
that need to be securely stored and accessed within your cluster.
Secrets. The Achilles heel of many applications. What does the guide recommend for keeping our sensitive data safe?
The guide rightly emphasizes that Kubernetes secrets,
Okay.
by default, aren't encrypted,
Right.
which is a major security
Yeah,
concern.
yeah, not very secure.
It's like hiding your house key under the welcome mat.
So what are our options for proper secrets management in Kubernetes?
The guide presents a few solid solutions.
Okay.
For a simple and straightforward setup, sealed secrets is a great starting point.
Okay.
It encrypts your secrets before they even reach your Git repository, adding an extra layer of protection.
So even if someone gains access to my code base, the actual secrets are still safe.
Precisely sealed secrets ensures that only your Kubernetes cluster can decrypt and access the secrets.
Oh.
It's a simple yet effective way to enhance security.
I'm sensing a theme here. Simplicity and security, a winning combination. What are some of the other options for secrets management mentioned in the guide?
For more advanced use cases, Vault by HashiCorp offers enterprise-grade secrets management.
Okay.
It provides features like secret rotation, auditing, and fine-grained access control.
Enterprise grade sounds impressive, but I'm guessing it also comes with a steeper learning curve.
You're right, Vault is a powerful tool.
Right.
But it's best suited for organizations with complex security requirements and dedicated security teams.
Makes sense. Are there any other options worth mentioning before we move on?
The guide also points out the external secrets operator,
Okay.
which is particularly useful if you're storing secrets in a cloud provider like AWS or Azure.
Right.
It allows you to synchronize secrets from your cloud provider into your Kubernetes cluster.
So if I'm already using a cloud-based secrets manager, I can leverage that integration directly within Kubernetes.
Exactly. It streamlines your workflow and avoids the need to manage secrets in multiple places.
That sounds incredibly useful for cloud-native deployments. This guide is really comprehensive. I'm starting to feel a lot more confident about my Kubernetes journey already.
It's a great resource for getting a handle on the essentials. But remember, the journey doesn't end here.
Of course.
There's always more to learn and explore in the ever-evolving world of Kubernetes.
Agreed.
Yeah.
But let's not get ahead of ourselves. We've covered a lot of ground already.
We have.
I think it's time for a well-deserved break.
Sounds good.
We'll be back in part 2 to dive into even more Kubernetes essentials. Stay tuned.
See you there. Welcome back.
Absolutely. We've laid a solid foundation with storage, ingress, security, and monitoring.
Yeah.
What's next on the agenda
Okay.
for making this Kubernetes cluster hum?
Let's focus on what Kubernetes is truly known for.
Okay.
Orchestrating those containerized applications you've been working on.
Containerization was a revelation for me.
Yeah.
It's like packing up your application and all its dependencies neatly into a portable box that runs anywhere.
Exactly. And Kubernetes acts as the conductor,
Okay.
orchestrating these containers across your cluster, ensuring they have the resources they need,
Right.
and keeping them running smoothly.
So it's like having an invisible army of tiny robots
Yeah.
handling all the tedious behind-the-scenes work.
Right.
What does the guide suggest for managing these containerized applications?
It highlights deployments as a key tool.
Deployments.
Think of them as blueprints for your pods,
Yeah.
which are the basic building blocks of Kubernetes deployments.
So a pod is like a group of containers working together.
Precisely. They share resources and networking.
Okay.
And deployments handle things like rolling updates, rollbacks, and scaling,
Right.
making it surprisingly easy to manage the entire lifecycle of your application.
That sounds incredibly powerful, especially the part about rolling updates.
Yeah,
No more downtime just to update my app.
you got it.
Wow.
Deployments allow you to update your application gradually,
Okay.
replacing old pods with new ones without interrupting service.
Nice.
And if a new version causes problems,
Uh-huh.
you can easily roll back to a previous version using the same deployment.
No more frantic late-night fixes because an update broke everything. Sign me up.
Great.
The guide also mentions replica sets. What role do they play in this container orchestra?
Replica sets ensure you always have a specified number of identical pods running.
Okay.
It's like having insurance for your application.
So interesting.
If a pod fails,
Yeah.
the replica set automatically spins up a new one to replace it,
Okay.
keeping your application resilient and available.
So even if a node crashes or a pod encounters an error,
Right.
my application can stay online thanks to replica sets.
That's the idea. They work hand in hand with deployments to ensure your desired state is always maintained,
Right.
even in the face of unexpected issues.
Resilience and automation Kubernetes is ticking all the right boxes.
Yeah.
Now the guide jumps into services. Are these related to deployments and replica sets?
Services provide a stable way to access your applications.
Okay.
Even if those pods managed by deployments and replica sets are constantly being created, deleted, or moved around.
So it's like having a permanent address for your application,
Yeah.
even if it keeps moving apartments within the cluster.
A perfect analogy.
Uh-huh.
This is crucial because pods are ephemeral.
Okay.
Their IPs can change,
Right.
but the service provides a fixed endpoint that other applications or external users can use to connect reliably.
Okay, that makes sense. But the guide mentions different types of services.
Well,
Why
yeah.
so many?
It cater to different use cases.
Okay.
Cluster IP services, for example,
Right.
create a virtual IP address that is only accessible within the cluster.
Okay.
This is useful for internal communication between your various services.
So if I have a front-end service that needs to talk to a back-end database service,
Right.
I'd use a cluster IP service.
Exactly. It keeps things organized and allows internal services to communicate without exposing them to the outside world.
And what about node port services? The guide describes them as a way to expose applications externally.
Node port services open a specific port on every node in your cluster, forwarding traffic to the underlying service.
Okay.
It's a straightforward way to make your application externally accessible,
Right.
but it might not be the most flexible or secure option.
So node port is like a quick and dirty way to expose a service for testing.
Yeah.
But for production, we'd want something more refined.
You got it. For production deployments,
Okay.
the guide recommends load balancer services.
Load balancer.
These integrate with your cloud provider's load balancing features,
Okay.
distributing incoming traffic efficiently across multiple pods and providing high availability.
It's like having a team of traffic cops directing visitors to the right booth at a busy festival.
Exactly.
Okay.
And finally, we have Ingress,
Right.
which we touched on briefly in the previous part.
I remember it being described as a smart router.
Yeah.
How does it fit into this whole service ecosystem?
Ingress sits in front of your services,
Okay.
acting as a more sophisticated entry point for external traffic.
Okay.
You can define rules based on things like domain names, paths, and even HTTP headers to direct traffic to specific services within your cluster.
So if I have multiple applications running in my cluster,
Yeah.
each with its own domain name,
Right.
Ingress can route those requests to the right places.
Precisely. It's like having a receptionist who knows exactly which department to direct each visitor to.
Okay.
Ingress simplifies your configuration,
Nice.
makes your applications more accessible, and can even handle SSL termination.
This is all starting to come together. It's
Yeah.
like Kubernetes is a city with a well-organized transportation system,
Yeah,
ensuring everything runs smoothly and efficiently.
that's a great way to visualize it.
Okay, now,
Now, let's zoom out a bit and talk about namespaces.
namespaces. I vaguely remember them being mentioned, but their purpose wasn't clear to me.
Namespaces allow you to divide your cluster into logical sections,
Okay.
like creating separate departments within your company.
Okay.
Each namespace gets its own resources and access controls,
Okay.
improving organization and security.
So I could have a development namespace for testing new features,
Right.
a staging namespace for pre-production testing,
Yeah,
and a production namespace for my live application.
exactly. This isolation prevents accidental deployments to the wrong environment and allows you to manage resources more effectively.
Namespaces sound like a must-have,
Yeah.
especially as my cluster grows and things get more complex.
Right?
But speaking of complexity, let's revisit secrets management.
Okay.
We talked about sealed secrets earlier, but how do I actually use these secrets within my applications?
You're right.
Yeah.
Securely storing secrets is just one part of the equation.
Right.
You also need a way to access them within your applications without compromising security.
I'm guessing hard-coding secrets into my application code is a big no-no.
Absolutely. That creates a major security risk.
Right.
Thankfully, Kubernetes offers several ways to inject secrets into your applications securely.
Okay.
One option is to use environment variables.
Environment variables.
So you could define your secrets as environment variables in your pod's configuration.
Right.
And Kubernetes would make them available to the application.
Exactly. It's a simple and effective approach.
Right.
Another option is to use volumes.
Yeah.
You can mount a secret as a volume within your pod,
Mhm.
allowing your application to access it like any other file.
Right.
Volumes seem like a good choice if my application needs to access the secret as a file,
Yeah.
like a configuration file or a certificate.
And for even more robust secrets management,
Okay.
you can explore dedicated tools like secrets managers or cloud-based key management services.
Right.
These offer features like automatic secret rotation, auditing, and fine-grained access control.
So I can start with environment variables or volumes,
Right.
and then level up to more sophisticated solutions as my security needs evolve.
Precisely. The key is to choose a strategy that balances security, convenience, and your specific requirements.
Now, I'm curious about how Kubernetes manages all these resources.
Okay.
It's like a juggling act,
Right.
keeping all these containers, pods, services, and namespaces running smoothly.
That's where resource management comes in. Kubernetes is all about efficiently allocating resources like CPU, memory, and storage to your applications,
Right.
ensuring they have what they need without overconsuming and impacting other applications.
It's like a budget for your cluster,
Exactly.
making sure each application gets its fair share
Yeah.
and preventing any one application from hogging all the resources.
And the way Kubernetes does this is through resource requests and limits.
Okay, requests and limits.
Requests define the minimum resources a container needs to start.
Okay.
Limits define the maximum resources a container can consume.
So requests are like a baseline guarantee, and limits are like a ceiling to prevent runaway resource consumption.
You got it.
Okay.
And Kubernetes uses these requests and limits to schedule pods onto nodes,
Right.
ensuring that each node has enough resources to handle the workload.
It's like a Tetris game,
Yeah.
where Kubernetes tries to fit the different shaped pods onto the nodes in the most efficient way.
That's a great way to think about it.
Uh-huh.
And if a pod needs more resources than are available on a particular node,
Uh-huh.
Kubernetes will schedule it onto a different node with more capacity,
Okay.
or wait until resources free up.
This is all incredibly sophisticated. It's like Kubernetes is a self-managing,
Yeah.
self-optimizing system that takes care of all the complex resource allocation behind the scenes.
It really is impressive.
But let's not forget, Kubernetes itself also requires resources to run.
Right.
How do we manage that?
You're right. Kubernetes components like
Sure.
the API, server, scheduler, and controller manager
Okay.
also consume resources. You can specify resource requests and limits for these components as well,
Okay.
ensuring they have enough to operate efficiently without impacting the performance of your applications.
So even Kubernetes needs a budget.
Haha,
I
exactly.
appreciate how everything comes back to this idea of resource management and optimization.
Yeah, it's fundamental.
It's a theme that runs through every aspect of a Kubernetes cluster.
Absolutely.
Huh.
Understanding resource management is crucial for running a healthy and efficient Kubernetes cluster.
We've covered so much in this part, from deployments and services to namespaces and resource management. It's clear that Kubernetes is a powerful,
Yeah.
complex beast.
But don't be intimidated. Remember the key takeaways from this deep dive.
Okay.
Start simple.
Uh-huh.
Focus on the essentials.
Right.
And don't be afraid to experiment.
Yeah.
Kubernetes is all about learning by doing. We'll continue our exploration in part 3 with even more Kubernetes insights and practical tips.
Looking forward to it. See you in part 3. All right, we're back for the final stretch of our Kubernetes Essentials deep dive.
Okay.
We've tackled storage, security, deployments,
Yeah.
and even resource management. What's left on our journey to Kubernetes mastery?
Let's dive into the world of Kubernetes networking.
Oh boy.
It's a fundamental aspect
Okay.
that often trips people up, but it's surprisingly elegant once you grasp the core concepts.
Networking is one of those things that always makes my head spin a bit.
Yeah.
What does the guide highlight as the key things to understand?
The foundation of Kubernetes networking is the idea that every pod gets its own unique IP address.
Okay, so
This means that pods can talk to each other directly,
Right.
regardless of which node they're running on.
it's like each pod having its own phone line,
Yeah,
able to call any other pod directly without going through a central switchboard.
exactly. This simplifies communication
Okay.
and eliminates a lot of the complexity you'd typically encounter in a traditional network setup.
That's pretty cool.
Yeah.
But how does this actually work in practice? The guide mentions something about networking plugins.
Right. Kubernetes relies on networking plugins to implement this pod-to-pod communication.
Okay.
There are several popular options, each with its own strengths and weaknesses.
Okay.
The guide mentions Flannel, Calico, and WeaveNet as common choices.
So choosing the right plugin depends on my specific needs
Yeah,
and the complexity of my network setup.
exactly. Some plugins are simpler to set up,
Right.
but might not offer the same level of features or performance as others.
Okay.
You'll need to weigh the trade-offs based on your requirements.
I'm starting to see why networking is often considered one of the more challenging aspects of Kubernetes.
Yeah, it can be.
But the guide seems to suggest that once you understand the core principle of pod-to-pod communication,
Right.
everything else falls into place.
Exactly. Kubernetes networking is designed to be flexible, scalable, and reliable.
Okay.
And once you've chosen a networking plugin that meets your needs, you can largely forget about the underlying complexities.
That's reassuring to hear.
Hmm.
Now, Let's switch gears and talk about security.
Okay.
We touched on secrets management earlier,
Yeah.
but what are some of the other security considerations we need to keep in mind?
Security in Kubernetes is multi-layered.
Okay.
The guide emphasizes securing your infrastructure, your applications, and your cluster itself.
So it's like a fortress with multiple layers of defense,
Yeah.
each designed to protect against different types of threats.
A good analogy.
Ah.
At the infrastructure level,
Okay.
you need to secure your nodes, your network, and your control plane.
Right.
This includes things like firewalls, intrusion detection systems, and strong authentication mechanisms.
These sound like standard security practices,
Yeah.
but I imagine they become even more critical in a Kubernetes environment.
Absolutely. With Kubernetes, you're essentially managing a distributed system with many moving parts.
Right.
Securing each component and the network connecting them is crucial.
And what about application-level security?
At the application level,
Okay.
you need to secure your containers, your images, and your code.
Okay.
This includes practices.
So it's not just about securing the Kubernetes platform itself,
Right.
but also ensuring that the applications running on it are built and deployed securely.
Exactly. And finally, at the cluster level,
Where?
you need to implement role-based access control, RBAC,
Mhm.
limit resource usage,
Right.
and monitor for suspicious activity.
RBAC sounds familiar. I think
Mm.
we touched on it briefly when discussing namespaces.
Right. RBAC allows you to define fine-grained permissions
Okay.
for different users and groups within your cluster.
Right.
This ensures that only authorized personnel have access to specific resources,
Okay.
minimizing the risk of accidental or malicious actions.
So it's like having security guards at each door,
Yeah.
checking IDs and ensuring that only those with the right credentials can enter.
A perfect analogy.
And resource limits play a crucial role in security as well.
Yeah, they do.
By limiting the amount of resources a container or pod can consume,
Right.
you prevent any one application from hogging resources
Right.
and potentially disrupting other applications or the cluster itself.
Exactly.
So resource limits are not just about efficiency,
Yeah.
but also about preventing denial of service attacks or other security issues that could arise from unchecked resource consumption.
Precisely. And of course, monitoring is crucial.
Yes.
By monitoring your cluster's activity,
Ah,
you can detect and respond to suspicious behavior or potential security breaches quickly.
it sounds like Kubernetes security is a multifaceted challenge,
It can be?
but the guide seems to offer a solid framework for addressing these concerns.
Absolutely.
Yeah.
By following best practices and implementing the appropriate security measures at each level,
Right.
you can create a secure and robust Kubernetes environment.
Now, I'm curious about the troubleshooting aspect.
Okay.
We've talked about all these different components and best practices.
Yeah.
But what happens when things inevitably go wrong? How do we even begin to troubleshoot issues in such a complex system?
Troubleshooting in Kubernetes can seem daunting,
Yeah, for sure.
but it becomes much more manageable
Okay.
if you approach it systematically.
Yeah.
The guide emphasizes gathering information as the first step.
So before we even try to fix anything,
Right.
we need to understand what's actually happening.
Exactly. Check logs, monitor metrics,
Right.
and inspect the state of your pods, services, and other resources.
Gotcha.
It's like being a detective, gathering clues to piece together what went wrong.
And what are some of the tools we can use for gathering this information?
Okay.
The guide mentions Kubectl.
Kubectl is your command line Swiss Army knife for interacting with your Kubernetes cluster.
Okay. The Swiss Army knife.
You can use it to view logs, describe resources, and even execute commands inside containers.
So Kubectl is like our magnifying glass, allowing us to peer into the inner workings of our cluster.
Exactly.
Nice.
And once you've gathered enough information, you can start to narrow down the root cause of the problem.
Right.
This might involve checking your configurations, examining your code, or even digging into the Kubernetes documentation or source code
Yeah.
if you're feeling adventurous.
Troubleshooting in Kubernetes sounds like a continuous learning process.
It definitely is.
The more you understand the system,
Yeah,
the better equipped you are to identify and resolve issues.
absolutely. And don't be afraid to ask for help.
Right.
The Kubernetes community is vast and supportive.
Okay.
There are countless resources available online,
Yeah, for sure.
including forums, blogs, and documentation.
This has been an incredible deep dive. We've covered so much ground,
Yeah, we have.
from the basics of storage and networking
Right.
to the complexities of security and troubleshooting.
Yeah,
I'm feeling a lot more confident about my Kubernetes journey,
that's great to hear.
but I know this is just the beginning.
You've summed it up perfectly. Kubernetes is a powerful platform that continues to evolve rapidly. Embrace the learning process, experiment, and don't be afraid to push the boundaries of what's possible.
And that brings us to the end of our Kubernetes Essentials deep dive.
It does.
We hope you found this journey informative and insightful.
Yeah.
Remember, start simple.
Start simple.
Build gradually.
Build gradually.
And always be learning.
And until next time, happy Kubernetesing.